so there's this huge demand from all these big tech companies with their big GPU services. There's tons of small startups like my own that need access to these for our generative AI capabilities in our platform. And despite all of this need for GPUs, because of CUDA, that NVIDIA, this amazing software CUDA that NVIDIA has, they maintain almost a monopoly on GPU usage. There's alternatives out there. AWS has their Trainium and Inferentia alternatives. Intel has alternatives. I think AMD has alternatives. But we don't really see those being taken up, even though there is this far more demand than capacity amongst NVIDIA GPUs.
Right. So I think you're saying an important thing. It's partly and importantly the software layer. And it's not only about CUDA, it's about the drivers, it's about all the little details of the stack. And NVIDIA has been really good at making sure that the stacks work really well with NVIDIA. And so indeed, it ends up creating a bottleneck. And here, I always go for simplicity. What matters to me is impact. Impact, say, in healthcare. And in many places, the evidence is we don't always need very complex models. They actually may be counterproductive because they're harder to audit. And so, there's two things about this. First, there is, some form of fashion of going for the complex thing that sometimes doesn't pan out. And then second is, so NVIDIA has been providing excellent GPUs and excellent software stack. My question, I don't have an answer to this, is how much could we use simpler GPUs? And one of the bottlenecks today is the software stack. And from a big picture, it's disappointing because even the small data scientist working on a laptop has access to a GPU. Could that be used to speed up data science? I don't know.
Yeah, just like their Apple GPU. Yeah,
exactly.
yeah. That it is interesting. Like that actually, there's something really obvious there.
But it's a software stack problem. And back to the fact that we have an excellent working relationships with NVIDIA. NVIDIA goes out. NVIDIA doesn't only worry about their chips or their drivers or CUDA. They go out, they talk to people. They're currently funding someone who works on scikit-learn, but really works on scikit-learn, not on GPU and scikit-learn, on just making sure that scikit-learn is healthy. And that's the kind of relationship we have with NVIDIA, and I think it's very impactful because they try to understand the whole ecosystem and to make sure the whole ecosystem works well and works that well for their stack.
Yeah, and one of the wild things about this is how they called this so early. Like now, okay, it seems obvious, and they have become this entrenched player in artificial intelligence, machine learning, computing. But 10 or so years ago, when they would have made that call, and I think it was around the AlexNet moment that NVIDIA's CEO decided, let's go all in on this. This is going to be big, because AlexNet was using 2 GPUs, but that was a risk. We didn't necessarily know that deep learning was going to take off the way that it did, and that GPUs would be the obvious choice. And so, yeah, remarkable that NVIDIA made that what would have seemed like a big bet at the time, kind of going all in on machine learning and AI, and getting involved up and down the tech stack across the ecosystem, like you're saying. And yeah, it's really paid off.
There's something fundamental about GPUs as in not graphical processing unit, but as in a different structure than the CPU. And whether it's GPUs, TPUs, you name it, but it's clear that there is an edge going to more vector processing unit. And indeed, AI is pushing this forward because it's basically a lot of numerical algebra. But it's if you think about a lot of numerical algebra, it's useful to think about new hardware. People have known this for a long time, and the question has always been, how do we make a compilation stack? And in this sense, what has happened in deep learning, which is basically, well, we worry about gradients, has been amazing. And this has empowered GPU. The question is, how can this carry over to other kind of machine learning? It's harder.